Okay, I'm back, and now we want to talk about the bands of Jupiter. Each of those bands is a convection cell. So if you remember, Earth had 3 convection cells in the north, and then it had 3 in the south for a grand total of 6 convection cells. If the Earth was not rotating, then the Earth would have just 1 convection cell in the north, and it would have 1 convection cell in the south. But because the Earth is rotating, it causes the Coriolis effect, and then that Coriolis effect bends the winds so much that they cannot make just 1 convection cell, and so it breaks up into 3. Now, Jupiter is rotating faster than what the Earth is, so it has more Coriolis effect, which means it has more convection cells. And so Jupiter ends up having 22 convection cells. So it's got like 11 in the north and 11 in the south, and then each of those convection cells is a band on Jupiter. So I've got this little video here. See, NASA's Juno spacecraft reveals the depth of Jupiter's, and then it continues on YouTube. So see if you can find that video, and I want you to watch it right now, and I want you to pay attention to the direction that the clouds are moving in. So you'll notice that on some of the bands the clouds are moving from left to right, and then in other bands they are moving in the opposite direction. Same thing happens on Earth. So depending on which convection cell that you're in, the winds either tend to go from east to west or from west to east. All right, so watch that little video. Did you watch it? Okay, hope you did. It's pretty good. And so that illustrates the convection cells that are inside of Jupiter. The picture down there at the bottom shows you that the other Saturn and also Uranus and Neptune also have these convection cells, and these convection cells are causing the winds to sometimes they're blowing this direction, and sometimes the winds are blowing in the opposite direction. Jupiter also has a magnetosphere. So let's go back to the Earth, and we said the Earth also has a magnetosphere. And that was a geodynamo, and it was caused by liquid iron and nickel in the outer core of the Earth. So as this liquid iron and nickel goes around and around, because the Earth is spinning, that is creating a geodynamo that causes Earth's magnetism. So what would be on Jupiter and Saturn that would create their magnetic fields? So it would need to be something metallic, just like on Earth, it's the iron and nickel. So what would be metallic on Jupiter and Saturn? Well, that's going to be that metallic hydrogen. So as that metallic hydrogen goes around and around, because Jupiter and Saturn are rotating, that's going to create a geodynamo. Now, if you look at that picture there, you'll notice that Jupiter has a huge magnetic field compared to all the other planets in our solar system. And just for comparison purposes, do you see that kind of a purplish blue box down there at the bottom? Okay, that is the magnetosphere of the Earth in comparison to the magnetosphere of Jupiter and Saturn, Uranus and Neptune. So our magnetic field is pretty small compared to those other planets. So we're going to take a break, and when we come back, now we're going to talk about Uranus and Neptune.